reflections, here we go. So reflections are rather simple. You are either going to reflect it about the y-axis, the x-axis, or some equation, craziness. But I've given you a kind of a format. I'm just going to give that to you again so that you can see it. I'm going to give you kind of a way that they're going to tell you to do it as well. So here is a shorthand version of what I've already given you. If you're doing a reflection, I'm going to indicate that with an R. If you're doing a reflection over the y-axis, I'm going to do a subunit for y-axis. So a reflection over the y-axis involving whatever your coordinates are will end up giving you an opposite x but the same y. Okay, so if I was here, okay, drawing out this piece, and I had something at, let's call it 1, 2. Let's call it A. Okay, that's at 1, 2. Now I'm going to reflect it. So to reflect it over the y-axis, remember that's the one that goes up and down, it's just going to go on the other side, right? Exactly the same as where it was on the right. It's now on the left. So that's A prime, that's the image, and this one's going to be at negative 1, 2. So there's your example. There's your geometric representation, your picture. Any questions about it? It's beautiful, isn't it? Say it's the most amazing thing you ever saw. Tell me what to do. All right, next one. If it's a reflection over the x-axis, the same type of thing will occur. So a reflection of the x-axis to coordinates x, y will be pretty much the same as this one, except for now this one's becoming opposite. So it'll be the same x, however your y will change. So here's our geometric representation. We use the same point even, 1, 2. This time it's going to go across the x-axis. Remember that this is your x. So it's going to be the same distance, just opposite side. Bless you. So if that was A, this is A prime. A was at 1, 2. It's now at 1, negative 2. It's really easy to see when you draw it, but this is hopefully, if you start seeing these things, you don't have to draw it anymore. So you can save yourself a little bit of time if you don't have to draw it. Questions, comments, concerns? Okay, this one's a little different. I did not go over this one the other day. So this is the reflection over an equation this time. So it's a reflection of the equation y equals x. So before I go ahead and explain this, let me just show you what the picture of y equals x looks like. So here's your xy coordinate, or sorry, your xy plane. Knowing that y is the tall one, x is the long one. Your y equals x is everywhere that y is equal to x. For example, 1, 1, or 0, 0, or 2, 2, or negative 5,752, negative 5,752. 5, 5. Or 5, 5, as Levi wants me to put down. Okay? It is anywhere that your y and x are exactly the same. So what ends up happening is it just cuts your x and y axis kind of straight down the center right here. Okay? So there's your line. So that is the line that we're going to be reflecting it across. So I'm just going to like hatch it so that you can see it really well. Okay? So there's your y equals x equation. That's the line that shows that. So if I'm going to reflect something across the y equals x, let me show you what it's going to look like. I'm going to make your y equals x line straight up and down, just so that you can see it a little bit better. And I'm going to plot a point. I'm going to plot the point 1, 2. Surprise, surprise, right? So 1, 2 is right here. If I'm going to reflect it on the opposite side, watch what happens. I'm just going the same distance across the reflection. So I'm reflecting it. Of course, I'm estimating, but here's my reflection. So A is my first one. A prime is going to be my image. And I want to turn it back upright so that you can see. 1, 2 turned into what? 2, 1. Amazing, right? So all that happens is if we are doing a reflection of something over the y equals x axis, where x and y are my coordinates, then all I do is basically flip-flop them. My y becomes my x and my x becomes my y. Mind blown.
That's easy.
It is easy. It is very easy.
I know.
Oh, you're so smart.
I need that.
Okay, I could elaborate on this for a long time. Do we need to? No, I can just let y'all guys roll then? All right, get to it.